Assalamualaikum warahmatullahi wabarakatuh and greetings to everyone. I am Faezatul Alwani Binti Rahim from Sultan Idris Education University. Will present our paper entitled Displaying a Macroscopic View of Phase Transition Using Concrete Model. So this is my presentation outline. First, I will go for the introductions. Second, literature review. Third, methodology. Fourth, findings and discussions. And last is the conclusion. Theoretically, matters occurs naturally in 5 states known as solids, liquids, gases, plasma, and Bose-Einstein condensates. However, only 3 states of matter are highlighted in the Malaysian chemistry syllabus. The theory regarding the matter was initially introduced to Year 5, 11-year-old students in primary school. Students aged 13 or older frequently learn the matters topic as it is implemented in the science syllabus. The following level of Malaysian education includes the matriculation program in Malaysia and the Malaysian Higher Education Certificate (STPM), which also meet the concept of matter broadly. Understanding the physical state of each phase, which are solid, liquid, or gas, was easier to assimilate into students' understanding macroscopically because it can be observed with the naked eyes. However, it was difficult to associate with the submacroscopic level that requires students' understanding of molecules interaction that lead to phase changes. As a result, the students has misconceptions about molecules reactions, physical and chemical changes in matter, and the systems of atoms, molecules, and particles. Therefore, learning about the state of matters does not only involve learning sessions in class, but also involves the use of other learning methods, including experimental methods and the use of teaching aids. Since the topic of phase changes in the state of matter could be observed at a macroscopic level and needed students to engage with the real phenomena as it was included in the science practical session or experiments. By using the experimental method gives a vision of how the process takes place, which allows students to engage with the real phenomenon. Furthermore, according to research conducted by Kobun in 1968, students were able to absorb 50% of what they heard and saw because messages received through multiple senses are better understood and retained. Providing the learning session with the ability to allow the students to observe and gain direct experience with the phenomena should not be ignored. So the fountain of phase FOP model offers the same function as the experimental method, which provides a macroscopic view of the phase transition process. Therefore, using the FOP model as a teaching aid in explaining the phase change process is essential, as it allows the students to conceptualize the process by providing a clear image of the processes that can be seen with the naked eyes. The objective of this study aims to develop a concrete model named Fountain of Phase model, which includes the processes of melting, boiling, freezing, condensation, sublimation, and deposition. The model is then validated by the panel of chemistry educational experts at Upsi. This is the methodology, which includes 5 phases. The first phase is the analysis phase, which includes the process of literature review and need analysis. Next is the design phase, which includes a process of sketching. And during this phase, the materials and instruments needed are also decided. Next is the development phase, which includes the process of develop FOP model. Next is the implementation together with the evaluation phase, which includes of the process of model testing and model's validity. So this is the our needs analysis results. We gain a feedback from our chemistry teachers across Muallim Perak. For the question, is the state of matters topic need the students to think higher in order to answer the exam questions? Second statement is the questions regarding the state of matters topic is necessary to be asked in the examinations, which shows 64% of agreements for that statement. Next, we also gained that plate model and animation videos has been used as the method or model to describe the phase transition process of matter, and we also gain that all the teachers are interested to use as the teaching aids in the class. So this is a few pictures of the model's development process, and this is the FOP model, which consists of three tanks, which are solid tank, liquid tank, and freeze tank. Solid tank functions to show the process of deposition, sublimation, and melting. Liquid tank functions to show the process of boiling and condensation, and freeze tank functions to show the process of freezing. This is how to run the FOP model. A bowl of ice are needed and is poured into the left side of the tanks, and the melting process is clearly shown when the ice starts to melt and flow towards the liquid tanks. While for the sublimation and deposition process, we can be demonstrated on the right side of the tank by using a dry ice. So the sublimation is shown by the physical state of dry ice, which we know that it sublimates immediately at room temperature. So for the deposition process, a piece of copper is half immersed in the tank that contains the dry ice, and the deposition of metal occurs when a solid forms on the upper side of the copper. When the liquid from the melting process at the solid tank enters the boiling tank, it will fill the beaker. So the Bunsen burner is used to heat the beaker. The water is boiled until its vapor touches the upper parts of the funnel. The process demonstrates how condensation occurs. Students may easily see how the liquid might turn into gas through the boiling process. The water vapor that is collected from the liquid tank flows through the PVC tube into the beaker in the freeze tank. Then the dry ice is placed around the beaker, which causes the water to freeze about 5 to 10 minutes. So this is the data for the percentage of agreement that have been gained from our panel of experts. So for the aspects of usefulness and suitability, the experts have given 84% of agreements, which conveys that the model could give valuable information about the phase transition process. And similar to the experiment method, the FOP model is able to provide a concrete learning experience to the student as they can see the real phenomena of the phase transition process with their naked eyes. Next aspect is the designs. So we have gained 83% of agreements, which conveys that the model could attract the students' attention and it's more practical than the experimental method. Next is the user-friendly aspect. We have gained 71% of agreement, which conveys that the model easy to use and stress-free for the teachers. And the final aspect is the overall. We have gained 92% of agreement, which conveys that the model is an innovative teaching aid that provides a new alternative for teachers. So based on Jessica and Saronom in 2021, with the percentage of agreement 71 until 100%, the teaching materials is valid. The study's findings conclude that the FOP, a concrete model for depicting phase transition phenomena in the mathematics topic, is valid and potentially effective as one of the alternative innovative teaching aids. Majority of the experts was impressed with the FOP model. The FOP model could be a good substitute for the actual teachers to deliver knowledge in the classroom. By applying the FOP model, teachers will save more time because they do not have to demonstrate the experiments in the laboratory to make students understand. Providing the FOP model in the classroom is also expected to give students maximal knowledge, since they will not only see the proper image of the phenomenon but also focus their attentions on the learning sessions. The Q&A sessions based on the FOP model help students gain conceptual understanding at the submicroscopic and symbolic level. It is suggested that in the future, new ideas may be generated to make improvements in enhances the model to produce a more sophisticated and effective concrete model teaching aids. I think that's all from me. Thank you so much.